Today I want to talk about the moment of integral. And the definition of the moment of integral is for a particle. The integral equal to the mass product, the square of the distance between the particle and the axis of rotation. And so for a rigid body, the integral is equal to the triple integral of the density and the distance between the particle and the axis of rotation, dv. So since mu dv is equal to dm, so this integral is also equal to triple integral distance square dm. Okay. And we have the parallel axis theorem for two distant axes, z and z prime, and the distance between them is d, where the rigid body, the center of rigid body of gravity pass through the z-axis. Then we can have the integral z prime is equal to the integral z plus mass product, the distance square between them. And here is the proof of the parallel axis theorem. Since we have the integral pass through the z-axis is triple integral mu distance square dv, and the distance of since the axis is z-axis, so the distance between the center between the object and the axis will be x squared plus y squared. And since mu dv is equal to dm, so it is also equal to triple integral x squared plus y squared dm. And then we can have the integral of z prime is equal to x squared plus y squared is equal to x squared plus y squared dm minus 2d triple integral x dm plus d squared triple integral dm. And by the symmetry, we can have the 2d triple integral x dm is equal to 0. And then we can get our result. The integral of z prime axis is equal to the integral of z axis plus mass product distance square. And we can have the convenient method to get our integral. So we have the integral tensor. The definition of the integral tensor is for a rigid body of unpoint mass. We call it mk. And the moment of integral tensor is given by a matrix, 3 times 3 matrix, and it is integral equals to where the diagonal equals to 3 plus 3 matrix, and each entry is equal to sigma k from 1 to n mk the distance between the rigid body and the axis square and conquer delta ij minus xi k xjk, and it can be representation in a matrix where I equals to I11 to I33 and it is equal to IXX to IZZ. And since Quantum delta, definition of a Quantum delta is when 1 when I equals J and 0 when I not equal J. So we can have the following matrix where the diagonal entry is the mk plus 2 square sum, and we can have iyx equal to ixy equals to minus mk skyk, and also for izx and ixz and izy and iyz. So we can have the fast way to calculate the moment of integral, where it can be the integral can be equal to the m plus the n vector, and plus the matrix we have above, then plus n vector again, and where the n vector is equal to it's a direction vector from the rigid body to the axis of rotation.